Hi, welcome. I'm Antony Jones, and this is about Ethereum, why it's necessary, why it's useful, and a little quick demo of building an application, not building so much as checking out a seed project and running it. So, the short version. I used to work at EW, great company, lovely company. Blockchain developer as of January, so I joined a new company called Applied Blockchain, and they are not a consultancy, but like a partnership with blockchain companies. We build ICOs, we build blockchains, we build private, public, we build all sorts of things surrounding the blockchain. I'm interested in interesting blockchain technology, and I'm an investor, as they say, which could be speculation, could be gambling, depends on how you look at it. You know, there's a lot of different options there. And I worked, the reason I joined a blockchain company and the reason I got really interested in it at all is because I was working in a fintech company doing loans, and I went home one night after 2 years of building this company from scratch, and I thought, well, actually, you know what, I could probably build this whole thing using a smart contract, really quite simply. And so I sort of, looked at Ethereum, looked at Truffle. I thought, let's give this a go. And a few hours later, a bit of hacking away, I'd kind of got a proof of concept all ready to go. And so at that point I thought, well, you know what, why am I not using the blockchain? Why am I not in the blockchain? Why am I not sort of more involved in this? And so I quit my job and I joined a blockchain company, and I've been there a week now, so still a bit raw. Okay, so Bitcoin was the first blockchain. Essentially, Bitcoin is kind of the name everyone knows. Everyone's excited about it. Everyone's chucking their money into it like left, right, and center. Unfortunately, the problem with Bitcoin is the technology's old. If they want to make a change, they end up forking it. It's not as sort of adaptable as the technologies are. It was based on the B-Money white paper, which was a sort of white paper about building a virtual cash system, and it was also based on a white paper on reusable proofs of work. So these two things came together, didn't really work together. Distributed databases weren't there, and then sort of Satoshi Nakamoto, group, who knows what it is, they sort of they came together and brought these things into one thing called Bitcoin, wrote a white paper, published it, and suddenly people got excited and started going, well, I want to be involved in this. I want to have virtual money. Why not? So the blockchain itself is nothing really more complicated than a linked list. It's essentially the next block on in the chain says that the block before it has this particular hash, so that you know that if you break that chain at any point, the rest of the chain becomes invalid. That's actually a hard fork as well, but what that means is that you can't ever question anything that's sort of solidified in that blockchain. It's there for good. You can use it as a trust mechanism. You can say that is the gospel, as it were. So another thing about the blockchain, because it's a chain of blocks, you have your balance isn't really stored on the blockchain. What's stored is all the previous transactions that make your balance. So when you actually look at your wallet balance, what you're seeing actually is just the culmination of all those transactions in a row, and that's what you've ended up with. And it's an open public ledger. So the nice thing about it is everyone can see it, everyone can view it. It's nice for people who are honest and pay their taxes, and it's not so good for those who don't. So that's kind of like the basic kind of blockchain level thing. Another important part of this is transactions. So a transaction, technically, essentially, you can't. It's either true or false. It's one or the other. You can't sort of have half a transaction. It's not a transaction at all. It's just a bunch of stuff. So the nice thing about transaction is it means that the money goes into a block in the blockchain, and it comes out to the side. Ta-da! That's done. It's a done deal. And cryptography helps sort of guard that sort of transaction against adaptation by anyone else. I think that's about it, really. So just wallet addresses quickly. So a wallet address is basically a hash. It's a thing that is unique to your group of transactions. However, because it's the blockchain and it's a culmination of transactions, you can actually have multiple wallet addresses, which is probably one of the reasons that you can't really trace these transactions. You can by doing a lot of maths and following where transactions have gone, but essentially you can become semi-anonymous. So Ethereum. So Ethereum came along because the Bitcoin blockchain, as we know, it's proof of concept. It's very early stage. It's the first one. It's the name everyone knows. The thing is, it's old. It's sort of creaking a bit. Ethereum came along to kind of fix a lot of the problems that blockchain had. So it came along with smart contracts, which are ERC20 tokens, which we'll go into later. It's not necessarily made for a cryptocurrency like Bitcoin is made to be Bitcoin. It's called a coin, right? But Ethereum was made for more smart contracts. It was made for building a way of having a sort of a ledger of transactions. And it's a great jump off point to create your own currency. If you want to actually have your own coin, your name's Andy, you can have Andy coin, problem solved. So you can actually create a coin in 10 minutes. There's projects you can check out and just run, and there you go. You can start buying, selling, whatever you want to do. It's a great proof of concept. It's great for building applications very quickly and saying, look, I've blockchainized your problem. I've taken your problem, made it a solution. And there are currently, as a testament to that, there are currently 1,600 projects currently using it. And there's a site you can go and view them all and check out what they've done and see their smart contracts and stuff. You can actually view the smart contract source code if you actually are that interested in how it works and you want to make sure you're not getting scammed by some ICO. And it all executes on the EVM, which is the Ethereum virtual machine. So we'll go into that later a bit as well, but it's a specific virtual machine for running smart contracts that runs on a blockchain. So everybody who mines Ethereum and processes your transactions runs a version of the EVM. So why Ethereum? So Ether is the Bitcoin. It's the Bitcoin on Ethereum is called Ether, but it's not a currency. It's a way of paying for the transactions you make. Bitcoin has Satoshis, Ether has Wei, I don't know how it is, but it's 10 to the 18th of a Ether. And they're all these different little coins are named after the people who made a big impact in blockchain early on. So Szabo, Wei, Finney, all these people wrote white papers on various things, and all these things were taken by Vitalik Buterin, who was the creator of Ethereum at age 19. By the way, don't want to make you feel guilty, but he's done a lot. So yeah, all these people really influenced him, and he wants to provide testament to them. So all these little micro bits of Ether are actually these names. And then when you pay for a transaction in Ethereum, it is paid via gas. When gas is it's about, I think it's 1 billion, 1 billionth or 1 billion Wei, which is a tenth of an Ether or something. It's a tiny little bit. And gas price fluctuates because the network is only a finite size. So as it grows and grows and grows, more transactions go on, and we'll explain transactions taking over the network and grinding it to a halt almost. But the gas price can change. So it's almost like an auction. It's almost like bidding. You can actually end up with a faster transaction if you put more gas into it. And yeah, all Ethereum wallets that store your Ethereum can also store any of the ERC20 tokens that you might get. So coins like OMG, coins like there's a million coins. I think there's 1,400 different altcoins based on Ethereum, and you can store all those in your Ethereum wallets. It's just it's all free form. So ERC20, it's basically for programmers and coders alike. It's an interface. It's a set of particular methods you must implement in order to say, this is my currency. So you can implement your own currency by implementing that interface. You can store that in your wallet. You can give it out to people, whatever you want to do. And yeah, so it defines a set of rules, and as long as you abide by those rules, you've got your own currency. So EVM, this is a virtual machine. It's like a regular virtual machine, but it's got this gas concept. So the important thing about gas, it exists for a reason, and that is to restrict what you can actually do. So if you write an infinite loop on Ethereum, sure, you can do it, but you'll run out of gas eventually. So your smart contract can't be super inefficient because no one will be able to use it. The moment the gas runs out, things stop executing. You're basically paying for every single operation, every push onto a stack, every pull from a stack, everything you do on that virtual machine, you're actually paying for with gas. So, for instance, an add operation in a stack adds the last two values in the stack together, like an assembly language virtual machine. That only costs 1 Wii. If you want to store something, and the command is ss_store, it costs you 200 Wii. So actually, storage is very expensive. And a colleague of mine, I think last week, told me that the current cost of storing 1 megabyte of data on the Ethereum blockchain is actually $43,000 currently. So probably don't do it. It's probably not a good plan. So it uses gas limit operations. It's in combination with another thing, which is Solidity, which is the language it uses. Solidity is very carefully built, and for a regular program to look at it, they look at it and go, this is crap. This is the worst language I've ever seen. And people say it every day. But the point is, it's that way for a reason. It's done that way because it stops you doing silly things. You can't even say to an array in this programming language, what is the length of you? What is your length? You can't ask them. What you've got to do is, every time you add an item to that array, you've got to increment an integer, and that's your array length. And it sounds crazy, it sounds absolutely insane, but it's that way for a reason. Because if you do infinite loops and loads of array operations and spend loads of gas, you're going to crash the Ethereum network, and that doesn't work for anybody. So, smart contract written in Solidity. So, it's a bit like a stored procedure if you understand databases. It's a piece of code that's kind of running on this database, which is your blockchain. It's got a unique address, and a smart contract's got a unique address. So, like you can send money to an Ethereum wallet, you can actually send money to a smart contract instead. They operate on exactly the same way. The difference being that when it goes into a smart contract, it doesn't just sit there. In a smart contract, a bunch of programming tests go on, and then the outputs are driven from whatever the result of that smart contract was. Multi-sig contracts even more interesting. So you've got let's say you've got a single input of money, and in order to get the money out again, you want actually two people to sign off that they are happy that money to be transferred. So what you've got then is you've got two people making a small transaction on the network, and then out the other end comes, ta-da, there's your money. And until those two signatures are done, you can't have the money, and it kind of gets locked in that contract. Right, so how can I write a smart contract? So, Solidity, the old language. It's Turing complete. It's good. It's limited. So there's all these limitations. It's creatively named. The compiler's called Sol-C. I mean, why not? And it runs on the EVM. So, you can have a little demo as well. You can play with it on remix.ethereum.org and just write your own smart contract and see if it works. It won't, by the way. First time, promise. Here's an example of what the code kind of looks like. Obviously, it's quite a simple example, so it's certainly not by any means a useful smart contract. It's got some major glaring errors. You'll see if you look at the fact that you can actually only store one piece of data, and it's an integer. So if you enter into my smart contract and put some data in there, I can overwrite it, or I can read your data. It's bad, but it's a very simplistic programming example. Am I standing in the beam? No. Okay, good. Right, and it's a bit like JavaScript as well, except it's typed. You can actually do typed return values. You'll see here you've got a constant. You're returning an integer, unsigned integer. Right, so how can I use it? They're not useful on their own. No one wants to play with that. The general public don't want to anyway. So what you do is you build an application around it. It's called a dApp. It stands for distributed application, not dynamic. And what it means is you can have things like Ether Delta. So this is actually an exchange for cryptocurrencies built purely as a smart contract. And as you might imagine, the blockchain isn't the fastest thing in the world. It can be quite slow. But it's really nice because actually you can change, in the drop down in the corner there, you can change the version of the smart contract you're using. So it's always good if you've made a transaction into the smart contract to put some money in. You probably want to use the same version on the way out. A lot of sites will change something underneath and you'll be, who knows what's happening. A lot of this, if you look at that drop down actually and go to Ether Delta, you'll find a lot of them say, do not use exclamation mark, exclamation mark, exclamation mark. So there's obviously, it's early stage. CryptoKitties is a good example of an interesting smart contract. So this actually brought the network down. So it's not perfect yet. CryptoKitties is basically like a Tamagotchi, but for smart, for smart contracts and things. The nice thing about bringing the network not down, but to a halt, definitely, is that they saw a lot of scaling improvements they could make. It's a great way to test on the public, with people's real money. There's some exciting projects out there. There's things like a community-driven bank. So people who don't have a bank account don't have access to a bank account. Thailand, for example, have a very bad banking system whereby I think it's something like 70% of the public don't have a bank account, but they can get very easily an electronic wallet on their phone and they can start banking and using money and having this trust in the middle that has been talked about. Healthcare is a very interesting one as well. So Estonia are a very progressive country. They have a whole electronic system for their government. They have, you can look at your own medical records. Anyone can look them up if you allow them. You can give them access. With the blockchain built on top, they're looking at building this into, an absolute verbatim. You cannot possibly question my healthcare records. They can also use the results from that to predict patterns in healthcare and say, these people did this and they got this condition. And in the art world as well. So one was interesting to me because I watched a lot of Lovejoy when I was younger in the 1980s. The provenance is the most important thing in art, right? Because it says that a piece of art is genuine. And actually what they're doing is storing provenance on the blockchain. Also paying for art in Bitcoin, but that's probably illegal, so let's forget that bit. But they're definitely using it to provide proof that this art is a particular piece of art. So this is the scary bit. Let's build a dApp. So how this works, let's see. You've got the blockchain tooling. Truffle is the main, I'd say it's probably the most mainstream known Ethereum tooling project. It gives you the ability to write up a seed project, run some tests, write some smart contracts. It gives you the kind of whole package, the whole IDE, everything you want to do to build your own Ethereum dApp. They have a concept of truffle boxes. So truffle boxes are a way to, it's a seed project. It's essentially, if you want to use React, you want to use, Java in the back end, you check out a truffle box and it will contain all those libraries for you, ready to go, ready to start adapting. And much like Create React App, very, very quick and easy to go with. The blockchain is your database. Sol-C is built into Truffle, so you've got that immediate compilation. And then you've got something like you need to have a blockchain, and probably you don't want to pay for every transaction whilst you're trying to develop the application. So they have things like Ganache, which is a UI-based version of the blockchain. Test RPC, ROPS and Test Network. There's a few different things there that allow you to actually make real transactions. And also the nice thing is with Truffle, you can actually write tests in Solidity. So although it's a terrible, terrible language and everyone hates it, it's actually good because you don't have to context switch between writing your smart contract and writing your tests. So on the client side, it gives you all the stuff you might expect, all the stuff you want. It's going to give you things like Vue, Angular, Svelte, React, jQuery, whatever takes your fancy. It's going to give you build tools like Webpack or Gulp, and it's going to give you transpilers like Babel. Anything you might find in a modern day web application. The only real difference is you're using this blockchain as your database, or at least one of your databases. So we should probably build one. I'll talk through quickly the stages involved before we get onto it. So the first thing is you install MetaMask. So MetaMask is a Chrome extension that provides a library called Web3. Web3 is a JSON RPC, don't worry, it's going somewhere. JSON RPC library that allows your browser to communicate with the blockchain. So you install this MetaMask and it's a very nice interface. It's got a little fox that looks and follows your cursor. It's all very nice, wonderful. And then you enter your little seed password in there and you can start sending Ether here and there and everywhere into smart contracts. And then you install Truffle, and Truffle gives you that whole kind of environment to start writing applications in. And then in this instance, you unbox. Who wrote that? Sounds like a good project. Basically a repository from GitHub that will give you a seed project. And then you deploy your contracts, very important. If you don't do that, nothing's going to happen. Let's not forget that contracts are tied to a specific network. So when you're running Ganache, for instance, it creates a new network every time. If you deploy your contracts once and you kill a network and you start it again, they're not going to work. So next thing, run the application. You run with npm run watch. We did talk about, let's not talk about npm being how you build blockchain applications, but it is. This happens. And you've got your test wallet in MetaMask, and then you just pay a fee, and you can store your number. Okay, let's try and build this thing. This could be interesting now because we're going to change the view so I can see and you can see. All right, let's call it test. Yeah, I know. Okay, so first things first, we have Truffle installed. Yeah, it's installed. So let's make a directory. Cool, we've got tests. So let's do Truffle unbox. Unbox. Oops, unbix. Unbox. Come on. They say don't do live coding. I think I know why now. Okay, so we unbox my box. Oh, great. There's no internet, is there? I've got no internet. Okay, it's all right. I made one earlier.
We could give you the internet password, or was that?
You could. It's pretty complicated, though. I don't want to spend too much time, right? So anyway, if you did that command and it worked, this is what you'd get right here. So let's open up the Ganache. So I'm using Ganache because it's actually a really nice way of looking at the blockchain. It gives you your mnemonic, which is a way to recreate your wallets from scratch. It gives you 100 ETH in each wallet. Now, if I could spend that, I'd be rich. Great, wonderful. Well, half as rich as I would have been yesterday, but you know. And then essentially, you've got everything you need here, and you can see it's auto mining, so I'm constantly getting my blocks mined. So this is the mnemonic we're using here. So I'm in the way. This mnemonic will allow MetaMask to recreate my wallet and give me the money out of it, which is useful. So let's deploy the contracts. This may or may not work. All right. So now, oh yeah, we should run the application. That's a good option. So we run the application. Compiling. This is only compiling the JavaScript side of things. It's doing a bit of ES6 compilation, transpilation. And so now the application should be running. Let's check that's running. Now what I expect from this, I fully expect to get a big red error saying nothing works. Because, not connected to blockchain. So it's asking me, I'll zoom this in. It's asked me to check that all my settings are correct and everything else. The reason this is failing is because MetaMask with the fox, see the fox, has no idea what's going on. It's all about the fox. It's a good fox. So let's get back to localhost. Right, so what I do now, it's good, right? So what I do is I can restore my wallet from a seed phrase. And so I'll just restore that by entering my mnemonic from Ganache. Enter a password. And then, there we go, account 1. So I've got an account now. If I refresh this page, hopefully it will ask me to pay the transaction fee, ta-da, to store this number. So this seed project, by the way, comes with a contract in it that will store a number and then retrieve that number. So if I just pay this now, ta-da. So what I've stored here is a value of 5. And I'll show you that in code in a minute shortly. But essentially, it's storing a number on the blockchain and retrieving them from the blockchain. Very, very simplistic, but it's a good base for you to start going and then build your own currency or whatever else you want to do. So build your own ICO, actually, that's probably more profitable. So let's look at what we have in terms of this project just that makes this happen. Speedy. Okay, so in my source, I've got the usual kind of web stuff you might expect. I've got the application. I've got it's a Svelte component. Svelte's basically a bit like Vue. It allows you to put the JavaScript, the CSS, and the HTML all in one thing. It does the bindings for you, and it compiles to pure JavaScript, which is why I really like it. And that's why I built this box, because it's just my current favorite front end du jour. So you've got the whole component here. That's just, yeah, actually, good point. Yeah, sorry. I can't read it on here, so I don't know what I'm saying. It's not big enough. Okay, so now you can read it, right? No? Okay. Okay, so it's just plain HTML. The smart contract there. So the next part of this application is the interesting bit. It's the contracts. So there's two contracts in here. There's a simple storage, which is for storing a number. And you basically got the exact same contract you saw before. And now you see it working. You put a number in, you change the number, and it stores it and it retrieves it. And then you've got migrations. And migrations are probably the complex part. Like a database, like a blockchain, you eventually have to migrate data across. There are no migrations in this project. It doesn't make sense to have any, but they're a critical part of Ethereum, and it's probably something you should think about when you're thinking about making a live production application, that at some point you've got to migrate data, and I hear it's extremely hard to do. And what else is in here? Not a lot, really. It's a relatively simplistic web application, and that's literally how easy it is. As long as you've got Truffle there giving you the ability to deploy smart contracts, it's as simple as that, really. You can add your migrations here. Again, there aren't any. They're very non-existent. And probably the other thing worth mentioning, I suppose, is the Truffle config. So you'll see that I've set a few, variables. The network ID doesn't matter because it's local. It's definitely it's just an insecure network. It's a star. But localhost 8545, which is where Ganache is running, so that my application is talking to Ganache, and Ganache is talking to the browser via MetaMask. And that's it. So, let's find presentation again, huh? There we go. Finished. So there's some links there that might be useful if you want to read more, or just come and talk to me in the pub, which I'll definitely be there, drowning my sorrows. Thank you.
So probably the dumbest question you'll get all night.
Probably not.
Whose computers is Ethereum running on? So when your app talks to the blockchain, like who actually owns the kit that it's running on?
So it's people. It's anyone who wants to run an Ethereum node. Anyone who fancies getting... Basically, if you mine a block, you get a reward for that block. There's a thing called reward halving, so that eventually it gets less and less profitable, but the idea being the network's big enough by that point. Also, I believe that if you make a transaction and your transaction has too much gas, as a miner, you might retrieve that extra gas. And also, if someone else found to be fraudulent, you can get gas from them as well. So there's a few benefits to being a miner. So ideally, the goal being that the community picks that up, that task.
So second question then. So when your app first needs to go and connect out to the network, how does it choose, which particular kind of node to go and connect to, and how does it know that that's trustworthy, that it's actually genuinely part of the network and not? Well,
trustworthiness it doesn't know, because you connect to one side of a fork, you don't know which side you're on, I suppose. The goal being that every transaction needs to have a set of confirmations. So you should never believe the transaction unless you've got those confirmations in place. As for how does it find the first node, like the discovery process, I actually don't know, but I assume that there's some sort of centralization somewhere that provides a list of nodes. Maybe someone else knows, I don't know.
Sorry, one more question.
Sure.
Visual Studio? Visual Studio?
It's really good. It's really good. I know I'm totally anti-Microsoft, but it is very good. Atom's great. And Sublime's wonderful, apart from paid. But Visual Studio is really good. Not an advertisement, it's good.
Wow.
The what, sorry? IntelliJ is very good, but it's very heavy for writing Solidity because you don't really get a lot from it. Like JavaScript, you only get so much from it. So yeah.
Anybody else?
What do you think about the scalability issues with Ethereum or Bitcoin in this case?
So, well, two completely different things. I think with Bitcoin, scalability has already been proven that it's a massive problem for them. I think that for me personally, not only because of the mining, the environmental impact in mining and stuff, but also because I feel that Bitcoin is the first of its kind. It's been a great proof of concept. It's wonderful. It's really made a change in the world. but it's now time for it to go away because it's really causing more problems than it's solving. All these kind of advancements on top of the what Bitcoin started have actually probably solving a lot of the problems whilst not having those same impacts as well. And I think for Ethereum scalability, like I said, they don't fork every time they have to make a change. There's not this massive CFD consensus discussion where half the network goes rogue and starts running some of the software. It's not like that with Ethereum. It's been a bit more kind of democratic, and the software's built to be adaptable, so you can actually solve these problems yourself. Additionally, like if you make your own token, if you use an ERC2 contract, you don't have to stay within the restrictions of what Ethereum provides per se. You can kind of go out of the bounds of that and sort of go on your own route.
But still, like, you have these limitations of the amount of transactions per second, and so
yes,
it doesn't scale with the amount of users. So supposing that there is a mainstream adoption of Ethereum, and it will eventually have the same problems that Bitcoin is having now. Yeah,
people tend to use Ethereum as a jump-off point. So they build their POC. It can handle quite a lot of transactions, but they then tend to use it as a POC and say, now this is working, the product works, the concept works, I'll start building my own blockchain. And the things like Ripple have come out of that, and things like Omis. Like Omis is actually still an Ethereum project, but Omis they've focused on transactions because they're a payment provider, and they're building their own blockchain. Their work on building their own blockchain has actually caused the creator of Ethereum to start looking more hard into Lightning Network. Is it Lightning or Plasma? One of the other two. Basically, it's Plasma. Lightning. So they've basically made it. These advancements have come, and he's now helping them out with that. So I think that these problems are solved by products that prove they have a use case for this kind of thing, and start building their own network and their own blockchain, and for whatever specific purpose and problems they need to solve.
Do you think you could kind of explain the radar network in layman's terms to me? How can that help Ethereum?
I have no idea about the radar network, unfortunately.
Okay.
So I guess the answer is no.
When do you decide, when you're starting a new project, when do you decide, or how do you decide that a conventional method of developing an application is definitely not going to work and it has to be developed as a blockchain application?
It's an interesting one. So I think the problem right now is that everybody looks at every single problem in the world and says, blockchain, I can solve it. And it's not the case. And I think there's a lot of that happening. I think the way that, especially the company I work for now, does it, generally it's driven by the client because they have this notion in their mind of what they want. What we tend to do is look at the kind of pros and cons of each different thing and potentially persuade them for something different. We judge what's a good blockchain for something based upon a few things. One is obviously suitability, but things like, is that blockchain does it have a community around it? Does it have all the developers? Does it have, all this help you can get? Because it's like any development task, I suppose. You Stack Overflow a lot of things. You need someone else to sort of encounter that first. A lot of our clients, are requesting certain networks, and we're like, well, we don't really want to do that because if we did that, we're going to end up being the first people to discover the first problem. So yeah, I mean, I think the problem right now is that. Blockchain seems to apply to everything, and I feel that eventually is going to die. Well, eventually, I say soon, is going to die off. I think what we'll see come to the surface is the real applications of blockchain, the good applications of blockchain. Margie talked about a few of them. The landscape is going to change a bit soon when the kind of hype dies down.
My question would be about different currencies, and there's, as far as I know, I don't know too much about it, but there's different currencies that are being exchanged on a central platform, which is like an online website. Is that centralized, or is there no kind of high risk of that being centralized and the whole system can be distributed? But if
so Ether Delta is probably one of the first examples of a truly decentralized exchange. It literally runs on the blockchain. There's no central store other than the blockchain itself. A lot of the exchanges out there now, if we look at Binance, it's become one of the biggest exchanges. It's a great site. It's much better than a lot of the other ones. It's very secure, very robust. But yes, it's centralized. And we look at Mt. Gox. It disappeared off the planet, and the founder was a very, very rich man for a long time, and then he went in jail. But it's one of those things that anything can be centralized and can be a super high risk. So I would like to definitely see more distributed platforms like EtherDelta in the future. If EtherDelta was more usable, I would use it more, but it's really not. It's quite a raw product right now.
Could you comment on the impact of quantum computing on the security of any blockchain, really?
Yeah.
So, as much as it's speculation at this stage,
sure.
Do you have any opinion?
It's a bit like when people started making ASIC-resistant blockchains. So people were mining the currency way faster than anyone anywhere expected because you've got dedicated chips to do that. If quantum computing is so efficient that it starts to break cryptography, or anything, in fact, not quantum computing alone, but anything that breaks cryptography, there's a problem. and people are genuinely worried about this, I think, and I think within reason. I think that if you look at what Bitcoin set out to do, or the way that it mines, the complex sum it solves is essentially guessing how many zeros on the front of a transaction hash. For me, that's breaking cryptography, right? That's intentionally trying to break it. And the better you become at that, the closer you are to breaking cryptography. So I think that, it's a genuine concern that quantum computing could end this whole train. I would just say withdraw before that happens.
In a similar fashion, let's say, not from the development point of view, but from the reliability point of view, how much better is a Turing-complete language like Solidity versus any other? Is it like less hackable, or is it?
It's the reason that Solidity is so kind of awkward is just purely because it's trying to keep efficiency down. It's not necessarily like a lot of languages are Turing complete. Solidity is intentionally difficult to use because they've made some restrictions. They've not implemented certain things you might expect to find in a modern language, so that you can't have this super high computational complexity on a node. Because essentially, it's very inefficient. Blockchain or smart contracts alone are very inefficient. That's why they're not smart, right? Because they're not efficient. You can write a thing that takes some money and sends someone else, but every single node on the network has to run that in order for that to be valid. So it's about keeping that computational cost down, keeping that stack low, and keeping the number of operations to a minimum.